Hi, class. We need to take a look at inequalities. And inequalities represent statements that represent solutions to expressions that technically have solutions that are infinite. So, for example, let me talk about the first example. So, the inequality that's stated here is technically x greater than 7. So, when we graph these inequalities, we typically mention where zero is at, and then you can actually label them in units of one. I'm just gonna move to 7, and the solutions to all the statements that fit into that mathematical statement of x is greater than 7 technically represent all values that are to the right of 7. So we're talking about 8, 9, decimals, fractions, any value to the right hand side. So when we're graphing x is greater than 7, or the solutions to that statement, we typically put a parenthesis because you're not including 7, and then you highlight every value to the right. So let me just make this a little bit thicker. And in this case, that's your solution. So we're talking about all numbers to the right hand side of, in this case, well, the values of 7, and technically not including 7 since 7 is not greater than 7. That's pretty much it. This is what your graphs are going to look like. They are asking for interval notation. So a way to express this with an interval, it's going to be, well, technically the parentheses means you're not including the lower bound. 7, 2, and then notice that any value greater than 7. So in this case, the infinity, but the infinity on the right, it's going to be positive infinity. That would be part of our solution for the interval. They're asking for the set builder notation, and the set builder notation is going to be as follows. So technically, squiggly bracket, then the variable that they're using. So in this case, x, and then all of these have a vertical bar. This vertical bar represents such that. And then in this case, x is greater than 7. And technically, x is a real number. And let me just write what the vertical bar means. That means such that. So in this case, the solutions to the statement x is greater than 7 represent every value to the right of 7. The interval notation is technically parentheses 7 towards positive infinity, and then the set builder notation. This portion here could also be expressed with symbols, and the symbols are the following. X is an element of the real numbers. That funny looking E represents element. And then the double R, real numbers. Let me do another one just so that you see another statement for inequalities. And this statement says x is less than or equal to 10. So technically, you're going to have the values of 0 here. I'm just going to put 10. And notice that this is a less than or equal. So that means that we're including the values of 10 here. And when you're including a specific value, you put a bracket. So a bracket on the notation and then also on the interval. So in this case, bracket and every value to the left. That's going to be technically our graph. Actually, I never boxed in our solution for the previous one. The interval notation technically is going to be from negative infinity to the values of 10 with a bracket. So all the interval notations, you're writing them from left to right, from min to max. The set builder notation, it's going to be the set of x's such that, and then in this case, x is less than or equal to 10, comma, x is a real number. And then I'm closing the bracket. So in this case, I'm closing the bracket. And this is going to be our solution. So that's pretty much it for inequalities. As I mentioned, they represent solutions to expressions that have an infinite amount of solutions. Keep in mind that when you're graphing, they represent all the numbers to the left. Let's move on to problem C. And you are going to have some of these that are giving us fractions. So we always mention the values of 0 just for reference in terms of position. And then I'm just going to put on this one, technically the values of 1. And then this is going to be 1/2. Now we're looking at the inequality of x is greater than or equal to 1/2. So technically bracket here and every value to the right. That's going to be our solution. The interval, we're going to use bracket 1/2 towards positive infinity. Min to max. So we're writing as min to max. It goes all the way to the positive infinity. The set builder notation, the set of x's such that x is greater than or equal to 1/2 and x is a real number. I'm just using the symbol for this one. That's it for this one. Let's move on to D. Okay, so on D, it says x is less than 2.3. So technically this is 0. I'm going to put 1. I want to put 2. And then I'm just going to put that this is 2.3. Obviously not to scale. And then this one says less than. So let me just make it a little bit thicker. In this case, less than is going to be a parentheses. And we're talking about every value to the left. Interval notation, parentheses, technically from negative infinity to 2.3 and parentheses because it's a less than statement. Set builder notation, squiggly brackets, x is such that x is less than 2.3 and x is a real number. And that's going to be our solution for this one. I'll do the other ones on a different video because they represent technically absolute value ones. But that's pretty much it for problems. Problem 1, A through D.